Yeah, hi guys, welcome to the present session. Yeah, I hope I'm audible and my video is also very fine. So if you're having any problem with the audio and video, please let me know in the comment section, guys. Okay. And yeah, so in this session, we are going to discuss about the second unit of our electronic science UGC net, that is IC fabrication. So before going into the main content of this video, first of all, welcome to the India's largest learning platform, that is Unacademy. And to get the updates regarding the further classes, please subscribe the channel and then tap the bell icon. And myself, I am Aswini Kumar, the educator of electronic science as well as the general paper 1. And Unacademy is providing the free course, free online classes as well as the paid courses also. So coming to the free online classes means you will get on the two platforms. So one is on Unacademy YouTube. So just like whatever the session is going on, so it is Unacademy YouTube platform, okay, where the free online classes will be available. In the same way, the special classes also available to you. So these special classes are also free online classes that you will get in the Unacademy app. Okay. And if you check the description box of this video, there my profile link is there. Okay, so go to my profile and then their follow button will be there. Just click on the follow button and then you are going to get the updates regarding all my special classes. Okay, there the special classes will happen so mostly on the paper one, and here in Unacademy YouTube the free online classes are going on electronic science. Fine. So it will be beneficial to you to follow the special classes in Unacademy app. Paper 1 will be covered, and in Unacademy YouTube channel the paper 2, that is electronic science, is going to be covered. So if you want, you may join, guys. And regarding the schedule, each and everything, coming to the special classes, you can check down in my profile, okay, in the Unacademy app itself, regarding the schedule of the special classes. And coming to the Unacademy YouTube sessions, every Monday, Tuesday, Wednesday of each and every week, daily evening 5 to 5:30, these Unacademy YouTube free classes will be available. Fine. And coming to the paid courses, so out of all the six, I want to highlight mainly fifth one and sixth one, because which is going to run from August 18th onwards. So it is a crash course on paper one as well as electronic science, and this crash course will be really helpful to the candidates who are preparing for the December 2020 cycle candidates. Okay, so the interested candidates may take the subscription plan for this one. The subscription link is also available in the description box of this video, so you may check down. And here the 1 month price, 3 months price, 6 months, 14 months, and 20 months. Okay, and out of all these plans, I am suggesting you to take the 3 months of the subscription plan. Okay, so if you take the 3 months, whatever the current courses are running, you may join on online sessions. Whatever the previous courses already completed, you can watch the recorded videos, guys. Okay, how many months you are taking the subscription plan, those many months you can able to access any educator's content. Okay, that means let's take the paper one. So not only mine, so many famous educators are there for the paper one, so you can access those videos also. Fine. So how many months you are taking, those many months you can access the content regarding the UGC net category. Okay, so and here I am providing my referral code ASWINIKLIVE. Okay, ASWINIKLIVE, Aswini K Live. It is my referral code. So use my referral code, then you will get the 10% discount on any one of this subscription plan. Okay, so these are the things regarding the announcements. And now we will start our session regarding the UGC Electronic Science second unit, that is IC Fabrication. So in the last month, okay, whatever the YouTube sessions I took, there I gave the introduction regarding the each and every unit, starting from unit 1 to unit 10. And while coming to the in this unit, in this month, I designed the YouTube sessions to deal the important topics from each and every unit. In that way, yesterday session, that means yesterday 5 to 5:30 session, okay, I discussed about the PN junction diode, which is the most important concept under the UGS, under the unit number 1. And in the same way, today in the second unit, the most important topic that we are going to see is the inverter. Okay, inverter we are going to see. And actually we are having the inverters as per our syllabus. NMOS inverter is there, as well as the CMOS inverter is also there. So first let's have a look on the NMOS inverter clearly, and then we will go to the CMOS inverter. Fine. Yeah. So basically, what is the inverter actually? What is the inverter? In the households also we are using the inverters. Means whenever the power supply is there to the inverter, then its output will be off. Whenever the power supply is off, then the inverter comes into on state. That means it comes into action, right? That is the case. In the same way here also, we're going to take the symbolic diagram of the inverter as like this. If you're giving 0 here, you will get 1 here. If you're giving 1 here, and you will get 0 here. Correct? Right? Yeah. Good evening to all of you whoever watching, guys. So here it is mentioned that 3 people are watching. So will you please tell me hi? Fine. So yeah, it is a thing of the NMOS inverter. And while coming to the design, NMOS inverter means you have to get the inverter action, and you have to design the inverter only based upon the N MOSFETs. You should not take any other MOSFETs. Okay, fine. The total 3 different types are there. One is NMOS inverter with resistor as a load, and the second one NMOS inverter with depletion MOSFET as a load, and the next one NMOS inverter with enhancement N MOSFET as a load. So total these are the 3 different types are there. Let's check clearly one by one. The first one, NMOS inverter with resistor as a load. So in this case, take one resistor. It is a VSS, it is a VDD and resistor, and from here we are collecting the output, and it is the input. Okay, so now whenever we are giving the input as a 0, then this N MOSFET will be in the off state, then this VDD completely connects to output, then you will get output as a high. And whenever the input is high or else logic 1, then this N MOSFET comes into on state, then the VDD shorts to VSS, then you will get output as a 0. Correct? So now it is satisfying the inverter action for giving, if the input is 0, you are getting VDD as output, and if the input is 1, you are getting output as a 0. So it is the inverter. Okay, NMOS inverter. And now in this case, what is the drawback with this one is that whenever we are fabricating the resistor in the integrated circuits, it occupies, resistor occupies more space, and this resistor will be continuously taking the power, right? Even though if you are operating or not, this resistor continuously taking the power, so the power consumption or the power dissipation will be more. Okay, these are the 2 points that we can take from this one. And next, so it is done with resistor as a load. And coming to the next one, we're going to see the second one with depletion N MOSFET as a load. So in this one, we are taking the depletion N MOSFET in the place of load, and we can also tell that In the pull-up section place, the depletion MOSFET we took. So it is a circuit, and it is the input, and it is the output. Fine. And now whenever here the depletion, if you observe this depletion MOSFET or the pull-up section, here the gate and source VGS, that means VG minus VS becomes is equal to 0. Why? Because gate and source, both these two are short circuited, that means VG is equal to VS. But while coming to the depletion MOSFET, whenever the gate voltage is 0 with VDS non-zero, it comes into conduction. So it acts like the roll, just like a resistor in the previous case, and here also the depletion will be in the continuous on state whenever the VDD is high. Okay, so but comparing with the previous two drawbacks, here one drawback can be eliminated. What is that one is, instead of resistor we are using the depletion type of MOSFET, so the space occupying will be reduces, right? So previously we took that the resistor occupies the more space, okay, more space, but here we can reduce the space. Why? Because we are taking the transistor in the place of the resistor, so occupies the less space. But the depletion MOSFET will be continuously in the on state, so due to its continuous on state, the power dissipation remains same, that means power dissipation will be more. So comparing with the previous case, out of the two drawbacks, one drawback is eliminated, but still one drawback is there. Fine. Next, go to the third one. Third one is we are taking enhancement N MOSFET. Enhancement N MOSFET as a load we are taking. Okay, if we consider the enhancement N MOSFET, then what will happen? Means, see guys, so it is a VDD, it is enhancement N MOSFET, and it is also enhancement N MOSFET, where we are giving the input signal here, and it is a VSS, and it is a control signal, and it is the output. Okay, so here whenever the control signal is 1, then only it starts consuming the power. Whenever the control signal is 0, it won't consume the power. Fine. So based upon this one, what we can understand here, out of the two drawbacks in the first case, both the two drawbacks can be eliminated. One is it occupies the less space, and the second one is okay, it will not be continuously in the on state. The on and off state of this one depends upon the control voltage, so the power dissipation can be reduced. Fine. So total these are the three different types of cases as per the what we call NMOS inverter. Fine. And one more most important point we have to discuss, that if the NMOS inverter is driven by another NMOS inverter, then what is the ZPU by ZPD ratio? Okay, Z is nothing but impedance, pull up section impedance and the pull down section impedance. What will be the ZPU by ZPD? Fine. Okay, let's take here the input is V suffix I and V. Okay, and it is going to this one. So in this one, if you consider the second case means, what is the second case we discussed in the above three? NMOS inverter with the depletion N MOSFET as a load. So take this one as like that. Now what will happen is that, yeah, so VDD, it is a depletion MOSFET, gate and source short circuited, and it is enhancement N MOSFET, VINV, and it is the output. Fine. So now if I am giving the input as a 1, let's take that both the two MOSFETs are in the on state, and both the two MOSFETs are in the saturation state. So both the two MOSFETs are in saturation state means, usually whenever the enhancement N MOSFET is in the saturation state, generally what is the current expression we are writing? I is equal to mu n COX W by L VGS minus VT into VDS minus VDS square by 2. Okay, so we'll write like this. So now if I'm taking the saturation case means what will happens? VGS minus VT. Okay, saturation case. VDS will be greater than or equal to VGS minus VT. Fine. Usually we will take like this. And in this one, if I am taking the equal to expression, then VDS becomes is equal to VGS minus VT. Now substitute this one in this above expression, then what I will get the drain current? Mu n COX W by L VDS square by 2. So finally it is the current flowing through the MOSFET in the case of saturation. Yeah guys, so it is a case of the current in the saturation point. Fine. So now we are taking that both the two transistors are in the saturation mode, right? So now if I can able to apply this equation to the depletion MOSFET as well as to the enhancement MOSFET. Okay, so are you clear about this one? Now if I am applying this equation to the depletion MOSFET, okay, so whatever the MOSFET is there to this one, then says I is equal to mu n COX W by L, and in the case of VDS here, in the case of VDS, I can take the VGS minus VT, right? Take the 2 here. So VGS minus VT whole square. Okay, so I'm taking like this. Now, if I'm going to apply this equation to the depletion MOSFET as well to the enhancement N MOSFET, both these two, and let's check that how the equation is changing. Okay, fine. So if I'm applying this equation to the depletion MOSFET, then I'm just writing here depletion MOSFET. Then 1 by 2 mu n COX WPU by LPU. Why I took the PU and PU? Because it is the pull up section and it is the pull down section. Okay, so WPU by LPU. And what is the VGS in the case of depletion MOSFET? As I previously told that gate and source both these two are short circuited, then your VGS becomes is equal to 0, and I am taking like this. Okay, instead of VT I took the VTD. Why? Because threshold voltage of the depletion MOSFET. Fine. Okay, now I got like this. Next, if I apply the same expression to the enhancement MOSFET, then what I will get? ID is equal to, enhancement, right? So IE is equal to mu n COX WPD by LPD instead of VGS, because what I took the input to the enhancement N MOSFET, VINV. So VINV minus VT whole square. Okay, I took like this. Now in what we call in this circuit, the depletion MOSFET as well as the enhancement N MOSFET, both these two are in series. Correct? Series means the same current has to flow. That means whatever the ID is there, whatever the IE is there, both these two become same. Okay, so if I equate both these two equations, then what will cancel? Half cancels, mu n COX will get cancels. And what about the remaining expression? I am writing here WPU by LPU minus BTD whole square is equal to WPD by LPD VINV minus VT whole square. I will get like this. Correct? And now actually our task is to find, that means if one NMOS inverter is driving by the another NMOS inverter, then what will be the ZPU by ZPD ratio? That is our task. So first of all, what is the Z? Impedance. Impedance can be taken as L divided by W. Okay, impedance can be taken as length of the channel divided by width of the channel. So now this one may I take as like this, 1 divided by ZPU as per this expression minus VTD whole square is equal to 1 divided by ZPD VINV minus VT whole square. Okay, I can take like this. And finally, the ZPU by ZPD can be written as ZPU by ZPD from this expression. It can be written as minus VTD whole square divided by VINV minus VT whole square. VINV minus VT whole square. So it is a ZPU by ZPD ratio whenever the one NMOS inverter is driven by the another NMOS inverter. Okay, and after substituting the typical values in this one, then I will get the ZPU by ZPD as a 4:1. Okay. Okay, 4:1. Okay, it is the equation we will get, and it is a very most important, guys. Why? Because the previously we got this equation also. Fine. So if you are having any doubts in this one, whatever we discussed, then you may please express your doubt, guys. Next, if one NMOS inverter is driven by, let's take like this, is driven by the pass transistors, then what about the ZPU by ZPD ratio? Sometimes we get like that also. So in this case, the ZPU by ZPD ratio can be taken as 8:1. Okay, 8:1. So it is also most important point. So by this way we can take the NMOS inverter concept, guys. So from where I started actually, you may check down. So I started that NMOS inverter will be the 3 types by changing the loads. So all these 3 types. Okay, and then the ZPU by ZPD, if one NMOS inverter is driven by the another NMOS inverter, then what is the circuit and what is the current equation? Okay, so how to manipulate the given current equation to find out the ZPU by ZPD? As actually, what is the impedance? Okay, what is the impedance? And all these things we discussed. Okay, if the NMOS inverter is driven by the another, past transistors, then the ZPU by ZPD can be taken as 8:1. Fine. So what is this pass transistors means? Pass transistors are nothing but a series connection of the NMOSFETs. Okay, NMOS transistors. Fine. Series connection of the NMOS transistor can be taken as a pass transistors. Fine. And now, while coming to the next one, as in the starting itself we discussed that in this session we are going to see the NMOS inverter as well as the CMOS inverter. So in the case of CMOS inverter, we are taking the 2 different types of MOSFETs. One is a P MOSFET and second one is a N MOSFET. Okay, so take the VDD and VSS, like this. So it is the input and it is the output. Okay, so we're giving like this, and here you can check the logic also. Usually the P MOSFET, if you're taking the P MOSFET like this, if the input is 1, then it will be an off state. If the input is 0, it comes into on state. But if you take the N MOSFET, if the input is 1, it's in on state. If the input is 0, it will be in the off state. That means you may observe here that both these two MOSFETs are looking the complementary. Correct or not? Both these two MOSFETs are looking the complementary type of MOSFETs. Correct? So why complementary? Because if I'm giving one as an input to one MOSFET, it is off, but here in another case it is on. So both these two are the complementary MOSFETs, and we are using both these two MOSFETs in a single circuit. That's why it is called as a complementary MOSFETs, complementary metal oxide semiconductors, right? Okay, now, so if I'm giving the input as a 1 here, then it is in the off state and it is in the on state. Now output is connected to VSS, so I will get output as a 0. And if I am giving the input as a 0, then it is in on state and it is in off state, and now the output is connected to VDD, then you will get output as a high. Okay, so it is the case of operation. How come this is acts like a inverter? Fine. So now it is the case about the CMOS inverter. Fine. So and now in the pull-up section we are taking the P MOSFET, and in the pull down section we are taking the N MOSFET. Okay, why? Because the P MOSFETs are good for logic 1, and coming to the N MOSFETs are good for logic 0. Okay, P MOSFET is good for logic 1 and N MOSFET is good for logic 0. So that's why in the same MOSFET we are taking the advantage of both the P MOSFET as well as the N MOSFET to get the very good swing. So in the same MOSFET, the thing is that power dissipation will be less, and the noise margin is also less. And coming to the voltage swing will be more. Okay, so these are all the advantages of the CMOS inverter. Fine. Yeah, hi Akshaya, good evening. So how are you? Yeah. And here, while coming to the VA characteristics of the CMOS inverter, actually we can explain with respect to the 5 different regions. Okay, but here I am just giving you the VA characteristics. So we can take like this. It is the output and it is the input. So whenever the input is 0, your output is more, and whenever your input is high, your output will be low. Okay, that's what the inverter operation is. And later onwards, okay, we are dividing this one into the regions 1, 2, 3, 4, 5 different types of regions. So in each and every region, what happens, what is operating condition of the P MOSFET and N MOSFET, all these things will be discussed. Okay. And the power dissipation of CMOS is less, or ECL. Yeah, Akshaya. So coming to your point, Akshaya, usually power dissipation and the speed of the circuit. Whenever the speed of the circuit is more, power dissipation is also more. Okay, power dissipation also more. And all of you know that ECL is the fastest logic family. That means its speed is more. Obviously, its power dissipation is also more. So in the ECL case, in intercoupled logic, the power dissipation is very high. And while coming to the CMOS, the power dissipation is less. Why? Because it is not as much as speed as intercoupled logic. Fine. So power dissipation and the speed, both these two are the optimizing parameters. If you want to look for the betterment of one thing, it leads the worse of the another parameter. Fine. That means if you want to reduce the power dissipation, your speed also reduces. Correct. So that's why the power dissipation of the CMOS is less. Is it clear, Akshaya? Did you understand? Yeah, fine. I think some delay is happening between I am teaching and you are watching. Okay, why? Because live streaming means some delay will happen. So that's why after asking my question, after 2 minutes or 3 minutes, you are reaching that question. Okay, no problem. Anyhow, so it is the case of the CMOS, right? So, and in the same way, in the exam, if they ask you what is the ZPU by, ZPU by ZPD ratio of CMOS inverter, then go for 2.5. Okay, 2.5 is the ZPU by ZPD ratio for the CMOS inverter. Okay, so finally, these are the in brief topics regarding the each and every case. Okay, so in tomorrow session we will meet with the next unit, guys. That is the network analysis. Okay, same timing 5 to 5:30. Okay, so thank you very much, guys. Yeah, thank you very much, Akshay. I think you joined at the last moment. Yeah. Yeah, Akshay, no problem. Fine. So tomorrow, every week, Monday, Tuesday, Wednesday, 5 to 5:30, it is our electronic science YouTube session. And coming to the special classes in the Unacademy platform, that is in the Unacademy app, in the description box of this video, my profile link is there. So just click on that one. Okay, and then in my profile link, you will find out the follow button. Click on that one. So whatever the updates are there, you will get the notifications. Okay. Okay, guys. Thank you very much, and bye, Akshaya. Thank you.